Hey all, we're back and we're going to be visiting and discussing the third, right, the last of our family of what we called fossil fuels, right? Remember, coal, oil, and natural gas. And the reason I wanted to talk about natural gas last is because it really is tied to the other two, right? It's actually, in both cases, it's kind of a byproduct. But we'll be able to explore that a little bit later in this discussion. So the first thing we want to talk about is use, right? So this is actually rehashing some of these diagrams you've seen before. We can see here this is world energy, and on that stage, obviously coal, petroleum, those are kind of heavy hitters. We don't use petroleum for power so much in the United States, but there are a lot of places that do. Then you can see this blue wedge down here is natural gas. So it's significant on the world stage, and then shifting our view again to this is the 2015 power grid or the power portfolio for the United States, and in this case you can see natural gas is giving coal a run for its money, and that's a concept that we'll explore. We've actually talked about that a little bit in the context of coal, right? How it's natural gas has some significant advantages. The first thing that we need to kind of remind ourselves is what natural gas is. So the first time we met gas, really, was in the context of our oil discussion. And remember that in that case, these extremely short-chained alkanes were a part of the fraction of crude oil. And so that's what we would really call conventional gas, right? Kind of regular old natural gas we've known about for a really long time. And actually, historically, it's always been a problem, right? So people weren't necessarily recovering that gas. In the early days of the oil industry, that the gas was lost or just wasted, because the gas, collecting and compressing and transporting is actually much more difficult than a fluid like crude oil. So again, I want to just take a quick look at our alkane chart and remember what our gases are here. So natural gas is mostly methane, in like 80-85% methane, which again is the shortest hydrocarbon chain that we have. It's CH4. It's the fundamental, tiniest one we can have. But there are a few other compounds that are also gases at room temperature. So bumping up in carbon chain length, right? We get ethane, propane, and butane, kind of the first four alkanes. But then after that, those are fluids at room temperature. So here we can revisit our fractionation column, all the way back to our oil discussion. And you can see, it's heated up in the furnace. It's brought into our fractionation column, and butane, propane, methane, and ethane are coming out the top as gases, right? So again, just to kind of help us put that into context. Something that we've been hinting about over the course of the past few weeks is essentially the amount of CO2 released per unit energy produced. And so here, I cannot remember if we've seen this diagram before. If not, we'll see it a couple of times here in this context. But this is a little bar graph that shows basically the volume of CO2 in kilograms produced per kilowatt hour of power. So all the way at the bottom we have wood, right? That's like your wood stove. It's not incredibly efficient, a large amount of CO2 produced. And then again, you see kind of the coal family down there in the lower portion: wood, peat, lignite, hard coal. Then we switch over to oil, but the really sludgy oils, right? Again, if you remember, this is the bottom of the fractionation column. So fuel oil, the stuff we use for ships, diesel, crude oil, kerosene, gasoline. And then up in the upper portion, all the way at the top, we see natural gas, which in this context of looking at all of the fossil fuels, you can see it really is kind of the best of the fossil fuels in the context of how much CO2 is produced per unit energy generated. So that kind of introduces us to a complicated notion, right? So we start to have to balance, what is more important, CO2 balance and kind of energy efficiency versus potential pollution problems associated with the recovery of natural gas. Again, that's not there's no easy answer to that. Those kind of two different views there. I used the term earlier in this discussion about I used the term conventional natural gas, and so remember, that's the gas that's a fraction of crude oil. That's something we've been dealing with since the 1800s, right? Since we've been extracting crude oil and using it, distilling it. But really, the natural gas revolution is something that kind of kicked off, you could approximate roughly 20 years ago, and this comes from actually not conventional reserves of natural gas, but a group of methods or a group of kind of types of geologic occurrence that we call unconventionals. So we're going to go through and look at a few examples of unconventional natural gas. Keep in mind that there actually are tons, and I really wanted just to pick on the big 3 or 4. I think we do 3, maybe we do 4. I'll have to again check my notes when we get there. But really, the natural gas revolution in most cases has been spurred by technological advancements. So these are drilling techniques or gas kind of handling techniques, things that have made it easier and more affordable for us to recover gas from reserves that we just really never did before.